Alright, here is a quick video on the quiz. These are fundamental questions and I'll just go through them as fast as possible so that you understand. Now, the first question talks about how many significant figures are in point 0067. To find the correct number of significant figures, the best method is to write it in the scientific notation. And in the scientific notation, you got to have the decimal place after the first non-zero digit. So in this case, the first non-zero digit is 6, and therefore got it has 6.7 times 10 to the negative 3, which means there are two significant figures. Simple. Now in the next question, you're given three numbers, three decimals, and you're asked to find the sum. Remember that when you multiply and divide, the rule for significant figures is that the product must have the lowest number of significant figures. But when you add and subtract, that is not the rule. When you add and subtract, the product must have the least number of decimal places. So when you look at these three numbers, you see that 1.9 has only one decimal place, which is 9. Therefore, the product should have only one decimal place, and therefore the answer is 6.6. In the third question, or the fourth question rather, a person walks a distance x northward and then 7x to the south, and if the total displacement is given as 400 meters, we know that the total displacement is from the starting point to the finishing point. So that much is given as 400 meters. Now, since that's x and this whole thing is 7x, from A to B should be 6x. So that's the key. So 6x is equal to 400, which means you get the value of x. And then to find the distance, you know that the total distance is actually x plus 7x, which becomes 8x. So the distance is 8x. So you get 8 times 66.7, which is 533 meters. There you go. Number 5 and 6. Here, the position of an object is given as a function of time. So you have a function there, which is 3t plus 2t squared. And you're asked to find the displacement of the object between 4 seconds and 5 seconds. Remember that displacement is the change in position. So you got to substitute the value of t into this function. First, t would be 4 seconds and then t would be 5 seconds. That'll give you the position at both 4 seconds and 5 seconds. And if you take the difference, you're going to get the displacement. So that should be very simple. So when t is equal to 4 seconds, you get 44 meters. And when t is 5 seconds, the position has changed to 65 meters. And the displacement is the difference between them, which is 21 meters. All right, number 6. An airplane is flying level, that means horizontally, and needs to accelerate from a speed of 200 meters per second to a speed of 240 meters per second. So there you have the initial velocity and the final velocity. And while it flies the distance of 1,200 meters, so that's the displacement. What must the acceleration be? Simple case of substitution. If you know the quantities, the four quantities given, then you know that the equation to be used is V final squared minus V initial squared is equal to 2 times A delta X. So that is why it's important to list the quantities given so you know which equation to use. And then rearrange that equation, substitute, and get the result. So the acceleration is 7.33 meter per second squared. That takes us to the 7th, 8th, and the 9th questions. Okay, the 7th question says a car starts from rest and accelerates with a constant acceleration of 1 meter per second squared for 3 seconds. So it first accelerates for 3 seconds and then the car continues for 3 seconds at a constant velocity. How far has the car traveled from its starting point? So you have two types of motion here. In the first case, it's accelerating, but in the second case, it's moving at a constant velocity. Now, therefore, to find the displacement when it's accelerating, you use this formula. Initial velocity is 0, so that whole term cancels out. You get 2.2. No, that is wrong. I'm going to correct that because I made a mistake of putting this as 0.5. Actually, it's 1. All right, so I have to. All right, so that's 1. Sorry for that mistake. And so the first part, it's 4.5 meter, but in the second type of motion, it's moving with a constant speed, a constant velocity rather, of 3 meter per second. Because that's going to be the final velocity after 3 seconds as given by this equation. And therefore, to find the displacement during that time of 5 seconds, just multiply the two, you get 15 meter. And then add the 15 meter with the 4.5 to get 19.5 meter. Which brings us to the 8th question. A speeding car is traveling at a constant 30 meter per second when it passes a stationary police car. If the police car delays its motion for 1 second before starting, what must the constant acceleration of the police car be to catch the speeding car after the police car travels a distance of 300 meters? Now, in this question, you need to understand that both the police car and the speeding car travel 300 meters. The difference is that the speeding car is moving at constant 30 meters per second. And so, to cover a distance of 300 meters at 30 meters per second, he's going to take 10 seconds. But the police car only has 9 seconds to catch up because he starts 1 second late. So the idea is that in 9 seconds, the police car has to travel 300 meters starting from rest. Here we go. So once again, time of travel of the speeder is 10 seconds. And since the cop starts 1 second late, he only has 9 seconds to catch up. His initial velocity is 0. So when you substitute into this equation, the whole first term becomes 0. And then you have 300 is 1/2 times 9 squared, which is 81. And then you calculate, you get 7.41 meter per second squared. Brings us to the 9th question. 2 objects are dropped from a bridge, an interval of 1 second apart. What is the separation 1 second after the second object is dropped? You've got to be careful when you read a problem. It says, what is their separation 1 second after the second object is dropped? Which means the first object has been traveling for 2 seconds, while the second one has only been traveling for 1 second. So the idea is to find their displacements in 2 seconds and then 1 second and find the difference. So here it is. That's okay. Here is it. For the first object, it has been traveling for 2 seconds. You're going to find the displacement. And since it's a freely falling object, A is 9.8 meter per second squared. Strictly speaking, it had to be negative 9.8. So let me add that negative there. So it's negative 9.8, which gives you negative 19.6 meter. For the second object, once again, using the same equation, you get negative 4.9 meters. So the difference between them is simply 14.7 meter. Technically, it would be negative 14.7 meter. So that's the answer. That brings us to the last question, which is a velocity time graph. And you're asked to find the displacement of a player in the 10 seconds shown. Now, the area of the velocity time graph gives us the displacement. So that's important. So all you've got to do is find the area of that graph, but you see that there is a negative part to this area and an equal positive part, so they will cancel out, see? And so what remains is two triangles, 1, 3, and a rectangle 2. Find the area of all three, add them up. The area of this triangle is 1/2 times 2 times 4. This is half times 2 times 2. And then this one is 6 times 2. Total 18 meter. That's it. So these are some questions that will help you prepare for any exam in physics. Thank you.